as well. So. All right, since you guys are here, you get to watch the transmission video from Dirty Jobs. If I can get it to come up. There we go. We'll probably have a commercial to watch. Oh, you know what? The sound got hijacked. Okay, so what kind of transmission was that? Oh. Yeah, so you review your different types of transmissions. That's droplet transmission, which is actually a type of contact transmission. It falls into that contact category. There is, I have got linked up there as well, and in the review activity for Unit 4, there's a little drag and drop activity that's real good for categorizing the different kinds of transmission. There's an animation in there as well, where it's like a cartoon type thing where a family's having dinner or something in a restaurant, and it shows you all the different kinds of transmission happening at once. Yeah. And then in Chapter 14, so we spent a lot of time talking about virulence factors, and just keep in mind that's anything that helps a microbe cause disease. So it can be some feature that they have on the surface, something they're secreting, anything that helps them out. If you go back in when you guys are working on your presentations at the end of the semester, be sure to include that type of information in your presentation, because the virulence factors are often what allow these organisms to make us sick in the first place. And so different types of microbes will have different virulence factors. I pulled this out of the back of the book for whooping cough just as an example of how diverse these different things are. So there are 3 key virulence factors for Bordetella pertussis. That's the type of bacteria that causes whooping cough. And the first one here is, there's that fimbrial. I'm referring to Fimbriae. Those are little spikes on the surface that help those bacteria attach to the inner lining of the trachea, which that's one of the key reasons why that type of bacteria causes whooping cough. And in addition to that, it makes a toxin called pertussis toxin that actually inhibits phagocytosis. So this is a weapon where it's actually fighting your white blood cells. And it also weakens other immune system components. That's another thing that some pathogens do. They have ways of weakening the different weaponry of your immune system. And as if all that wasn't bad enough, it also makes something called tracheal cytotoxin, which kills the ciliated cells along the inner lining, where the cilia help sweep microbes, yeah. So that's one of the key reasons why Bordetella pertussis can stay down in your lower respiratory tract and cause whooping cough. They are. But lots of them are, unfortunately. Okay, here's an example question. Microbes increasing in population in this part of the body must represent an infection. There's one place there where, there are 3 places on there where you would normally expect microbes. Yeah, it's going to be the pancreas, because the pancreas is a part of the body where you don't normally expect microbes. So if microbes get in there and they're increasing in numbers, you must have an infection. Microbes increasing in any of those other locations, they might just be normal microbes that are supposed to be there anyway. Let's see, select all that are true about the wall of the trachea. Pen doesn't want to come up. So again, just these types of questions, just read really slowly, go through them step by step. So how about A? Microbes are normally found in the connective tissues underlying the lining of the inside, down in here. No, you would not normally expect microbes there. The tight connections between the epithelial cells help prevent entry. Yeah. That one's true. The cilia help sweep microbes toward the bronchi of the lungs. No, yeah. Other way, up and out, yeah. The mucus on the surface of the epithelial lining helps trap microbes. Definitely. And pathogens that produce high hyaluronidase may be able to break the connections between the epithelial cells and gain entry into the underlying tissues. That's an enzyme, and it digests high hyaluronic acid, which is a carbohydrate glue-like substance that you do have between many of your cells. It's kind of like a tissue glue that would be present in here. So yeah, if you're a pathogen and you're up here and you can digest that tissue glue, it's going to help you invade deeper down in here where you're not supposed to be. So that one would be true. All right, suppose you are a microbiologist and you're involved with the Human Microbiome Project. That's the project where they're trying to identify what all these microbes are that live in various parts of the body. You have been assigned to collect swabs from various volunteers. Since the project encompasses the entire human microbiome, select all of the body locations that should be swabbed. So places where we would definitely expect to have normal microbes. So we'll just go through, axillary skin. Oops. Oh, well. ACDINL. So axillary skin, yes. Come on. Not your blood. Microbes get into the blood all the time, but they're quickly zapped. Epithelium at the end of the urethra. How about anywhere else in the urinary tract? As far as we know, no. Plaque on your teeth? Oh, yeah. Cerebrospinal fluid? Hopefully not. Epithelial lining of the bladder. Visceral peritoneum. That's the lining, the membrane lining that contacts the organs in your abdominopelvic cavity, yeah. No, hopefully not. Alveoli in the lungs. Epithelium of the nasal cavity. Heart valves, hopefully not. Liver, and that's something to keep in mind because the liver and the pancreas are classified as accessory organs of your digestive tract, and you do have microbes throughout most of your digestive tract, but not in the liver or the pancreas or the gallbladder, as far as we know. Surface of the eye, yeah, most of them get flushed off, but you are going to find some there. And then osseous tissues, bone, hopefully not. So do review where you're supposed to have microbes. And if you know where you're supposed to have microbes, what body fluid should have microbes in it, then everything else is a no. So the easiest way is to learn where you would normally expect to have them. And your textbook has a really good table that summarizes all of that really easily. If a pregnant woman develops septicemia, what does that mean? Yeah, blood infection. And when it's just septicemia, usually it's bacteria, but it doesn't have to be. Even if you had a viral infection of the blood, that would be a type of septicemia. But normally when that term gets used, people are really referring to bacteremia, where you have bacteria in the blood. All right, her developing embryo or fetus will also develop the infection since pathogens always cross the placenta. Yeah, that's false. Some do, unfortunately, but not all of them. Which of the following parts of pathogenic bacteria can directly help them become established in the body, and why? So here you want to look for things that pathogens would have, but non-pathogens would not. So how about a capsule? Yeah, that's definitely going to be one. What does a capsule do? Think of it as like a shield. Yeah. And what are your white blood cells trying to do to the bacteria? Yeah, phagocyte. Capsules are generally shields for phagocytosis. How about a plasma membrane? Any living thing has a plasma membrane, so that's not doing anything specific for pathogens. How about flagella? They can help. Motion, they can help them invade deeper parts of the body. And some bacteria use flagella for attachment as well. They multitask with their flagella so they can attach to tissues. Fimbriae, pili, yeah, those are attachment. Adhesins, those types of things. Anything that helps a microbe adhere is a type of adhesin. How about ribosomes? Not directly, because any living thing has ribosomes. M protein spikes. Yeah, those are your Streptococcus bacteria, have those. Streptococcus pyogenes. Mycolic acid cell wall. Yeah, and who has that? There's one organism in particular that we've talked about this. Helps protect it from drying out. Lots of things can't get past it. It's your TB, your Mycobacterium tuberculosis. Bacteria have that type of cell wall. Let's see. E. coli lives in the colon and synthesizes vitamin K for you. Which of the following is true? A, yeah. It's a mutualist. Mutualist means the organism is doing something beneficial for you. And in the colon, mutualistic, if it gets into the bloodstream or urinary tract or down in the respiratory tract, it's going to cause disease. This virulence factor of Staphylococcus aureus is an enzyme that helps the organism digest connections between cells, tissue glue, and invade more deeply into the body. Yeah, that's the high hyaluronidase we're just talking about. This one is also a virulence factor. What does that one do? Coagulase? Or it actually deliberately triggers a clot to form, and it protects the bacteria inside the clot in here. So that enzyme deliberately causes a clot to form around the bacteria. Staphylococcus aureus makes that as well. That's another virulence factor. Then the bacteria can hide in the clot. These enzymes break the clot apart. So the bacteria go inside these clots, build up their numbers, and then later they need to get out of the clot so they can move on to a new host. And those are called kinases. All right, let's see. Muffy is playing in the malfunctioning septic drain field in her front yard. She plays with some mud and puts her fingers in her mouth. She swallows 1,000 cells of Salmonella enterica and 500 particles of a rotavirus that has been causing an outbreak of gastroenteritis in her local area. Suppose the ID50 for Salmonella enterica is 10,000, and for rotavirus it's 100. So which of those would we consider to be more virulent? Your ID50. What's your ID50? What does that mean? Your ID50 is your infectious dose 50%. So that's the dose where if you exposed a group of people to that amount, half would get infected and half would not. So based on that, which of these two is going to be more virulent? The rotavirus, because it takes fewer. It only takes 100 rotavirus particles to infect 50% of the people who get exposed, but it would take 10,000 of the Salmonella enterica. Is Muffy likely to become infected with either of these two pathogens? She swallowed 1,000 Salmonella enterica, so is she likely to get infected? She might, but it's a numbers game. But it takes 10,000 to infect just half of the people. So if she only got exposed to 1,000, pretty good chance she's not going to get infected. Yeah, it depends on other factors. She has weak immunity. She's unhealthy. But in all likelihood, she's probably not going to become infected. How about the rotavirus? Yes. Yeah, she got 5 times the dose, so she's probably going to be puking her guts up and have rotavirus diarrhea. Many pathogenic bacterial species are covered by a capsule that helps shield the cells from phagocytosis. Yeah, that's true. Select each of the following that can help protect pathogenic bacteria from phagocytosis. Yeah, definitely A. This would be, M proteins are a shield against phagocytosis. D, no, actually, because all bacteria have cell walls, and actually cell walls are one of the things your phagocytes can latch onto. It's one of the things they're looking for. Coagulase, yeah, because they can hide out inside a clot. F, that's one of the things the mycolic acid cell wall does for your M. tuberculosis bacteria that have that cell wall. Fimbriae are attachment spikes, so they're probably not really going to shield the bacteria from phagocytosis. They're generally used for attachment somewhere. All right, suppose you work for a pharmaceutical company or you're trying to develop new drugs to treat necrotizing fasciitis. Your approach is to develop drugs that inhibit bacterial enzymes that are directly responsible for the kind of tissue damage you see over here. Which of the following enzymes could you consider trying to inhibit? So which ones of those cause severe tissue damage? B, yeah, because it breaks down tissue glue. And which one? Coagulase triggers little small blood clots, yeah. There's really just one more up there that's responsible for severe tissue damage. E, yeah, collagenase, which breaks down collagen, which you have in your connective tissues. So, yeah, your flesh-eating bacteria make collagenase. That's a big component in your connective tissues. And what do leukocytins do? Yeah, they kill white blood cells. And white blood cells are not like a major tissue component, so it's certainly going to help them establish an infection, but it's not really going to be responsible for the tissue destruction. Guido went for a polar bear swim in a frigid mountain stream as part of a twisted contest for a reality TV show. Several of his toes were frostbitten, and they have been colonized by Clostridium perfringens. This anaerobic bacterium produces a number of exotoxins that cause severe tissue damage. What term best applies for his condition? It won't be A, because A refers specifically to endotoxins. It won't be E, because viremia means you're infected with a virus. You have virus in the blood. And he doesn't have, it's not bacteremia, because the bacteria are not in his blood. This is an anaerobe. This is your gangrene organism. So it's in a local area, but it's releasing these nasty toxins that are spreading elsewhere in the body. Septicemia means the microbes themselves are in the blood. Yeah, so we're not talking. Yeah, toxins in the blood. And exotoxins, remember those are, here's your bacterial cell and it's secreting these toxin molecules. Those are proteins those get into your body fluids, bloodstream, and can travel elsewhere in the body. And when that's happening, you have toxemia. Endotoxemia refers specifically to endotoxins. And then what type of bacteria, what group have those? They're in your outer membrane. No, they're gram-negative. Endotoxin is the lipid A portion of LPS, of your lipopolysaccharides. And you have those in your outer membranes of your gram-negative bacteria. And they set off, your immune system reacts very strongly to endotoxins. Sets off a whole set of events, widespread inflammation. It can trigger DIC. We talked about little mini blood clots, which can lead to hemorrhaging because they deplete your clotting factors. So if you see DIC, think endotoxins, gram-negative bacteria releasing endotoxins. Bacillus anthracis secretes a toxin that binds to the surfaces of macrophages in the host, enters the macrophages inside a membrane-covered vesicle, exits the vesicle, and then is released in the cytosol. Once in there, the toxin functions as an enzyme. It inhibits the macrophage functions and can even kill them. So which group of toxins does this belong to? So your toxin attaches to the surface, comes inside, and does damage inside. Oh, my red pen's not showing up. Yes, the AB type. AB toxins, the B stands for binding to a cell. A is activity or action inside the cell. Endotoxins are released from dead gram-negative bacteria. They're actually part of the bacteria themselves. They're up here in the outer membrane of gram-negative bacteria. So if your bacterial cell is alive, they're locked up in there. But when this cell dies and gets digested, broken apart by your phagocytes, that's when those lipid A, that's your endotoxin, they get released and your immune system goes bonkers when it sees those molecules. We don't make these. That's a bacterial lipid and not one of our lipids. All right, you are working with a patient who's been at home for 10 days, hasn't come into contact with anyone else. She experienced violent vomiting and diarrhea just a few hours after eating some macaroni and cheese that had been left over in her refrigerator for several days. You are aware that many people in the local area have been infected with norovirus, which causes severe gastroenteritis. What do you suspect caused her severe vomiting and diarrhea? Yeah, food poisoning. And most likely, anybody remember what organism likely caused this? Nope. It's a pretty common one. Lots of us are carriers. Yeah, Staph aureus. Likely Staph aureus food poisoning. So that was growing in the macaroni and cheese. Unfortunately, it can grow in the refrigerator pretty well. Secretes a toxin, which is classified as a super antigen because it causes your immune system to go bonkers down along the intestinal lining. And it's also called an enterotoxin because it damages the intestinal lining as well. So you swallow those toxins, you get sick pretty quickly. What? You can find anything. You just go to Google Images, type in anything. You can. There's something in there. Puke it, yeah. Which of the following is a result of endotoxin release from pathogenic bacteria? And again, these are gram-negative bacteria that release this. It's the LPS, and it's really the lipid A part of the LPS. F, yeah, all of these things, the endotoxin, lipid A, triggers all of those different things. Especially if you have if a patient has gram-negative septicemia, and you have this lipid A that's released all across the bloodstream at one time, it just sets off a cascade of horrible things. And DIC could be in here as well, disseminated intravascular coagulation, those little miniature blood clots. And that can lead to hemorrhaging, where you can't clot your blood when you need to clot your blood. So those patients have a lot of really bad bruising. That's a side effect of gram-negative septicemia in some cases. Also, too, if a patient has gram-negative septicemia, you give them an antibiotic to kill the gram-negative bacteria. They can actually get sicker at first because you kill all these bacteria in the blood and all these lipid A's get released because your phagocytes start gobbling up all the dead bacteria, and that can set off all those nasty symptoms. So they might actually get sicker for a while before they get better. You have to be real careful with that too, because the patient might not be all that sick from the bacteria in the blood, but they get much sicker. All right, a mad scientist injects his research assistant with 20 million dead E. coli cells as part of a very warped experiment. He tells his assistant, Igor, not to worry. The bacteria are dead. Should Igor be worried? Why or why not? And E. coli is gram-negative. Yeah, just like what we were just talking about. These are gram-negative. Yeah. Could be bad news because you put all those bacteria into the blood, your phagocytes, those monocytes floating around in there, they're still going to engulf these dead bacteria, release the lipid A, and it's going to set off all those horrible...
You might not get E. coli, but you'll feel like it.
Yeah. Yeah, you're going to get sick for a while. Oh, I think we just did this. Food poisoning with rapid onset within a few hours is caused when people ingest. No, not the endotoxins are just that's referring to the LPS and the gram-negative. Yeah, enterotoxins, which affect the intestinal lining. Well, that's also a type of superantigen. Causes your immune system to go wild. Streptolysins, hemolysins, and leukocidins have a few things in common. Select all of the things below that apply. So how about A? Are they exotoxins of viruses? They are exotoxins, but not of viruses. The exotoxins, these are bacterial. So all those things that we talked about, those were bacterial pathogens that made those. Are those virulence factors? Yeah, because anything that helps an organism cause disease is a virulence factor. And those things are certainly helping those organisms cause disease. Are they endotoxins? No, endotoxin an endotoxin is part of the structure of the bacteria, only gets released when those cells die or they're phagocytosed or broken apart. These are things that live bacteria are secreting into their surroundings. So they're exotoxins because those toxins exit the cells. Are these membrane damaging toxins? Yeah, all of those are hole punching toxins. E, so E is protein Z, but yeah, that's what they do. They bind to the membranes of at least some types of human cells and puncture them. Could these lower the ID50 of a bacterial organism that makes them? Yeah, they could, because the ID50 is your infectious dose that's going to be capable of causing a disease in 50% of the people who are exposed to it. So any virulence factors you have lower your ID50. Because there are species of bacteria, and you have some strains that make these types of things, other strains that don't. The strains that do are more virulent. They're more likely to cause disease. True or false, epidemiologists only consider animals or humans to be reservoirs of infectious microbes. Yeah, that's certainly false. Because you can have non-living reservoirs as well, things like soil and water. If your son sneezes out common cold viruses onto the kitchen counter and then you touch the kitchen counter and transfer the viruses to your nasal cavity, this is an example of which type of transmission? A. Yeah, indirect contact transmission through a fomite. So what's our fomite in this example? Yeah, the kitchen counter is your fomite, any inanimate object. And that is classified as indirect contact transmission because the two people didn't have direct physical contact.
If he sneezes in space, then it would be droplet.
Droplet, yeah. And what's the difference? There's a distance.
Yeah, it's 7 feet, isn't it?
It's supposed to be 1 meter, a little over 3 feet, yeah. If it's beyond that distance, then it's considered to be airborne transmission. An airborne transmission is a type of vehicle transmission. So with transmission, you've got contact, you've got vehicle, and you got vector transmission. So like I was saying, the review activity on Blackboard has a pretty good review activity where you go through and categorize the different types of transmission. All right, you're getting ready to kiss your honey schnookums, and he or she sneezes in your face just as your lips are about to meet. Your honey has a coronavirus infection. Those cause some of our common colds and other respiratory diseases. Coronavirus. When you look at them under an electron microscope, they look like the sun, not like the beer. Yeah, they look like a sun, like the corona of the sun. The coronaviruses have now been transmitted to you. Select all that apply. So is this a type of contact transmission?
Yes. Forward.
It's right before you.
You got sneezed.
Got droplet.
Well, sneezing took place.
Yeah.
Yeah, that is. Yeah, droplet is in the contact category. Yeah. So this is a type of contact transmission. Is this a parenteral route of entry? You remember what that means? That's where you puncture the skin or mucous membrane.
No.
So no. Some people want to say yes because he's a spider, but I don't. The question doesn't tell us there's been any puncturing. No. Yeah, biting during surgery, a scalpel or any other kind of instrument piercing the skin or a mucous membrane is parenteral route of entry. Is it airborne?
See, that's where I get confused at, because I think anything in the air, when the same
Yeah.
would be airborne.
But here there are actual definitions for the two.
No, it's going to be droplet.
It's droplet, yeah. Airborne is technically beyond. If somebody sneezes or coughs out respiratory droplets and you're within 3 feet, it's called droplet transmission rather than airborne. Your coronavirus infected honey schnookums was the biological vector in this scenario. We're actually not biological. In order for it to be a biological vector, that's like a mosquito bites this person and transmits something to this person. The vector has to carry it from one person to another. So here there's no vector involved. They're transmitting to each other. So you're not a vector in that scenario. If Spider-Man bites her and then he carries something to somebody else and bites somebody else, he would be a biological vector. If you have to report morbidity data to the State Board of Health for a particular infectious disease, what would you be reporting? Which of these? Your morbidity data. Yeah, that's A is mortality.
Yeah, that's not right.
This is morbidity. That word can throw you off because it sounds morbid. Incidences, yeah, incidences of the infectious disease.
You feel like this is not your hardest test?
No, it's not.
Morbid and fatality.
Usually the grades are higher.
So morbid and fatality is two different things.
Mortality is the M word for fatality. Yeah, morbidity just means a change in the state of health. And I put more of the virulence factor questions in here because that's usually what people have the hardest time with. So this review is skewed more towards that type of stuff. Common colds have a duration of a few days, whereas influenza can last for 10 days to 2 weeks. Assume that epidemics of both infectious diseases are occurring in a local area with the same incidence rates, which will have the higher prevalence rate. So what's incidence versus prevalence?
It's just the
New cases during a time period, prevalence,
the last thing.
yeah, new and existing, yeah. So which is going to have your higher prevalence rate? Yeah, flu, because it lasts 10 days to 2 weeks. So if you're looking on a week-to-week basis, if you get sick in week 1, you're still going to be sick in week 2. That may not be the case for the common cold. And then things like HIV, which you never get rid of, wind up with very high prevalence rate if people are surviving with the illness. Julio feels fine, but recent blood work shows elevated neutrophils. He is showing blank, but not blank of illness. He feels good.
Yeah.
Which one?
Saying.
Right. He's showing signs, but not symptoms. Signs are something that can be detected, like elevated neutrophils with a clinical test, or you can observe it. Symptoms, the patient has to be feeling or perceiving. Bernice has experienced a terrible case of the flu, but noticed this morning that she is feeling better and her temperature has dropped to 99.8 from 102.5 yesterday. What disease stage has she entered? Yep, decline. She's getting better. She still has a fever. If you're in this stage, you're over the disease. You're still recovering. You're still repairing the damage. That's convalescence. Decline, you're still sick, but you're getting better. What are our disease stages? What's the first one? You get exposed. The microbes growing inside you. But you don't know, you don't feel sick yet. You don't know that it's there. What's that one? Incubation period. And that varies tremendously from disease to disease. Different microbes have very different incubation times. All right, then what is it called when you're starting to feel sick? You don't have the full-blown illness yet, but that one's one of your 4 choices up there, the next stage. Yeah, that's your prodromal. Pro means before. Dromal is referring to disease, before you're full-blown sick. Then you have your illness or disease stage. That's where you're really sick. Then decline, and then convalescence. Those are your different disease stages. Which of the following diseases is communicable? Yeah, D. Because what does communicable mean? Yeah, it can be spread. It has a natural way of spreading. It's naturally spread from one person to another, or one host to another. So none of those other things up there can be spread from one person to another. Even staph food poisoning, because that's just due to a toxin. People infected with HIV may transmit the virus to others for years before realizing they are infected. What's the main reason for that? Right. See, AIDS has a long incubation period. You've been exposed, the microbes are growing inside your body, but you have no clue that they're there. Granny Esmeralda returns to Krusty Hills Memorial Hospital after getting into a knife fight with her boyfriend Earl. The knife wound introduced Staphylococcus epidermidis bacteria into her dermis. Those are also called coagulase negative staphylococcus as well. They entered her bloodstream. She later developed E. coli pneumonia while she was hospitalized. So select all the following that apply in this scenario. A, Granny has been infected with the organism most commonly associated with sepsis. That one is actually true. If you go back and look over which organisms are responsible for your HAIs, your healthcare-acquired infections, staph epidermidis, good old friendly staph that lives on everybody's skin, is actually responsible for the most cases of sepsis in medical facilities. Her pneumonia is an example of an HAI, yeah. She got it in a healthcare facility. The staph bacteria entered Granny through a parenteral route. Yeah, because it was through a knife wound. That's a parenteral route. E. coli is acting as an opportunistic pathogen in this case. Yeah, it's not normally a pathogen, but when it gets into parts of the body where it's not supposed to be, it can take advantage of the opportunity. The pneumonia is an example of a latent infection. Latent would mean the microbe is dormant in the body and comes out later, like herpes. No. Since the Staphylococcus is a gram-positive organism, poor Granny is at risk of experiencing shock and DIC due to endotoxins. No, because that's that's something you get with gram-negative sepsis. All right, I think this one is the last one. We got a little mini discussion here. We have a water park outbreak. 30 children younger than 3 years of age developed gastroenteritis after visiting a local water park. These cases represented 44% of the park visitors in the age group on the day of the outbreak. No older individuals were affected. The causative agent was determined to be a member of the bacterial genus Shigella. Based only on this information, can we classify this outbreak as an epidemic? Yes, because what does an epidemic mean? It doesn't even have to spread. Spreading, because you have different kinds of epidemics. You've got propagated ones, like we did with our little candy experiment, where it is spreading from person to person, or you can have common source, or your textbook also refers to point source as well, where people who come into contact with something in common, they're the ones who get sick, other people don't. So an epidemic, in order to have an epidemic, you just have to have more cases of something than you would normally expect. So yes, this is an epidemic. Since 44% of the park visitors under the age of 3 got Shigella, hopefully that would not be a normal situation in a water park. Yeah. Although we have a water park down in Blount County where I wouldn't be surprised if this was.
It's very common for those little parks, especially those
Yeah.
little places where the water shoots up, and little kids are playing in there, and it just recirculates the water.
Oh, I know. Yeah. Water parks are notorious for outbreaks of stuff like this. I know there's a big one over where my parents live in Atlanta, Whitewater,
Oh, yeah.
and they've had outbreaks. There was one that was, it's probably been like 20 years ago now, but
And now you can like walk.
they had a
by,
nasty E.
feel
coli.
smell chlorine.
Yeah. That's right, yeah.
If you don't smell like chlorine, you're like, yeah, no.
There was some little kid, he was a toddler, he was in there with a diaper on, and he had a diarrhea-causing strain of E. coli. He's in there in the water park, a bunch of kids got it from him, so it's not unusual. All right, so if you were an epidemiologist, how would you determine which pools in the water park were contaminated?
The ones with the little kids.
Yeah,
Yeah, most likely the little kid. Those are going to be the ones you would suspect. But how would you know? What if they had like 10 kiddie pools? How would you figure out which one?
Have to sample the water.
Yeah, you can sample the water and test for Shigella. That's more likely how it would be done. What if all the Shigella is gone? What's something else in that? What would you do? And you've got to figure out, I got to know exactly which pool this was. Yeah, that's what they do a lot of times. They go around and survey, which pool or pools did your little kid who got sick swim in. They do that type of detective work as well. What factors might account for the fact that no older children or adults develop disease?
They could have had an age limit for
That pool.
Yeah, they're not in the pools. Sometimes parents go in those pools, though.
But
Depending on the age.
they don't drink the water usually.
Yeah, they probably don't swallow the water. Yeah. They might, though. They might get splashed in their mouth. They may have immunity. Little kids they haven't built up their immunity to various things we get exposed to. Adults would be more likely to have immunity to Shigella. That's one of those things a lot of us get exposed to at some point during our lives. So any of those types of things might account for it as well. All right, that was the last one. And in discussion questions on the test, be sure to review incidence and prevalence. And what we went over with HIV/AIDS the other day in class. And review HAIs and the types of precautions healthcare workers need to take. And your toxin stuff, review that as well. And there are 3 discussion questions on the test.